And I am live. That is cool. Today is 2nd of October 2025, Thursday, and we are in the big game now. We can start solving 1600 rated questions, as you might have seen from the title. And yes, that is going to be pretty cool. CP31. And if I go to my website, my profile, I must have done a few 1600 questions. One exactly, and this must have been in a contest. That is nice. And today we are going to start with this 1600 rated questions. And now there are 1600, 17, 18, and 1900 rated questions, and each one has 31 questions. That is 124 questions in total. And till now we have done 148. That is exactly double of what is remaining, and it is going to be pretty cool. Partition the array, and let's begin. Yo, hello, how are you? And you are also starting to stream, I see. You also plan to stream, and that would be cool. Not to stop watch 1600. And tomorrow is a contest. Currently, the rating is 1396. Almost a specialist. If I gain rating tomorrow, which I think I will, that would give me some like real credibility from a pupil to a specialist, and that would be cool. Like actually good. And with that, let's tmux kill server and tmux set attach pcp. We will create a new folder, of course, for 1600 rated questions and cd into the folder. Start new vim version 11.4, and this is not even like version 1 11 point 11, not 1.0. This is the question, and let's actually start this. Okay, cool. Alan has an array a1 to an elements for every positive integer k, that is for every positive integer k that is a divisor of n. Alan does the following. He partitions the array into n by k disjoint sub-arrays of length k. Okay, each array having a length of k. In other words, he partitions, Alan is a male. In other words, he partitions the array into following subarrays. K, yes, of size k. Alan earns 1 point if there exists some positive integer m greater than equal to 2, such that if he replaces every element in the array with its remainder when divided by 2, then all the subarrays will be identical. Help Aaron find the number of points he will earn. Okay, so n is going to have numbers. Okay, so n is the number of elements in the array, and k is going to be at least about log n. K is going to be divisors of n, the numbers that divide n, and n can even be 1. Okay, and then we have to find for particular k how many numbers m exist, such that if I were to take modulo m of all the elements in the array, these segments of size k would have the same exact array. Okay, and that is a good question. This is what we did yesterday. That is a good question. I mean, yes, it is 1600 rated, so that is a good question. Hello, hola, hola, amigo. Code with Anish by Aapsi. We daily one say stream. Shit, that is pretty cool. Amazing. Keep going. Is this Mac? Oh, looks so smooth. Yes, it is Mac. Look at this. Look at this. But yeah, it also has the downsides of being a Mac, right? I cannot, like, this does not natively support Linux things, which I might like. Good morning from Kinesis Advantage, fully wireless brown switches and thumb cluster, and Pinky Pain and brown switches is bad. I cannot stand Hyperline. What do you use then? Okay, okay. Yes, I would like to. I am working on a project, and I will become very powerful after that project, and I will be able to talk to you with like eye to eye. Shit, I window manager. i3 window manager. You said that earlier. On laptop, I prefer Mac aesthetics, and on desktop, Linux on Omarchy. Shit, bro is already onto it. What tiling do you prefer? Lol. What tiling do you prefer? Ah, shit. Okay. Yeah, you're talking to him. Okay. For the question, let me do my best. So we have n. First of all, we will have to find out k, all the k's which we can do in under root n time, going through iterating through numbers and seeing if they divide k, and yeah, that would be that we would be able to find in root n time, that is green somehow. And then after that, for each k, I think we don't even need to find. Our main goal is when we have been given this array, here n is 6 and the numbers that divide 6 from 1, k starts from 1, and for every positive integer k. Okay, so k starts from 1 and goes up till n. So 1 and n are already one of the keys which divide the list, and in this case we also have 2 and 3. So if we don't look at the answer and just at the question, we have something like this, and we have multiple ways. We have k equals 1, k equals 2, k equals 3, and k equals 6, and these are the subsections in which we can divide our given array. So when k equals 1, our array is going to look like this. We will have singular elements 1, 3, 1, 1, and 1 there, and 3 here. This is how our array is going to look like when k equals 1. And when k equals 2, our array is going to look like 1, 3, and 1, 1, and 3, 1. Okay. And when k equals 3, we will have 1, 3, 1, and a copy 1, 3, 1. And when k equals 6, we will have the same array. And now for each value of k, we need to find out a number m. And when we take modulus of each of these elements with m, these subsegments that we have of the original array, they will be identical to each other. In this case, if we take m equals, let's say, 3, right? If we take m equals 3 in this case, or let's say we take m equals 2 in this case, or in any case, when we take m equals 2, since all of these numbers are odd, we will have like the remainder modulus m will be 1 for each. So here for k equals 1, we want each of the number to be equal to each other, and they can be equal to each other if we take m. So if we take m equals 2, and we can take m equals 2, that is within the limit. Yep, m can be equal to or greater than 2. So we can take m equal to 2. So we will earn 1 point at this place. So that is nice. For k equal to 1, we get 1 point. And when k equals to 2, first of all, we can always like take m equal to 2. Again, yes, we can take m equal to 2. This will become 1, 1. This already is 1, 1. This will also become 1, 1. So that does work. Can we take m equals 3? No, that will not work. And m greater than that is not going to help in any way. And here we can take m equal to 2. That will just make these numbers same. And then we can take m equal to 3 also, because this thing and this thing when taken modulus 3 will return 101 and 101. So that is cool. That does work. That is cool. 1 and 2 points from this. And when we are taking this, then we can, then wait, there is no upper limit for k. That is a divisor of n, proper divisor. Because let's not look at this case right now, because we can take any m we want. Since there is only a single subsegment, it is always going to be equal to each other, so we cannot have infinite points. So let's say that we are going to have about 4 points, if I am correct, for this case number 4. 1 2 3 4, 4 points. Okay, so we are not going to look at this case, I suppose. Okay, so is there some pattern that we can see here? Shit, that is a lot of thing. Vim is good. Richard Stallman. Yes, Stallman is a nice person. And if you go to his website, he has photos of himself celebrating his birthday. Like, I don't know, everything is open source. His personal life is also open source. And yes, he abuses Ubuntu security things. Okay, is there some pattern? Let's solve a few more questions by hand. This thing, yeah, this is easy because here there are only 3 possible k values. One k value is just 1, which, yeah, one k value is just 1, and the next k value is 2, and the next k value is 5. So when 1, then yeah, we will have 10 segments with where each element is an array in itself. And can we find a m for it? Well, let's first of all make the arrays. So in this case, we have 2 arrays of size 5. In this case, we have that. And in this case, we have 1, 7 as one array, and then 5, 1 as one array, then 1, 4 as one array, and then 3, 1 as one array, and then 3, 1 as 1, 7, 5, 1, 4, 3, 4, 3, and then 1, 3, 1, 3, and then 1, 4. These are the arrays when k equals 2. Okay, can we have a m value here? The smallest m value that we can have is 2, but that would only make things same if their parity is same, and here the parity is not same, so that is not going to help. And if we take m equals 3, that is also not going to work. Like, yes, if we take modulus 3 of this thing, we will get 1, 1. If we take modulus 3 of this thing, we will get 2, 1. They are not the same. So 4, for 4, this will give 1, 3, modulus 1, 3, and this will give not, this will not give that, this will give 1, 1. And for 5, modulus 5, this will give 1, 2, and this will give 0, 1. So that is also not good. 6, modulus 6, this will give 1, 1, and this will give 5, 1. And that is also not good. And then we go to 7, and this will give 1, 0, and 5, 1. And after that, no point in taking anything. But here, can we do something? Since we want to, what are the limitations? Okay, proper limitations. There is no shorthand. We have full size of n. I think some advanced structure is going to be used here. N log n. Okay, here in this case, in this particular case, I think the answer is going to be 0 in this case. Let's see. This is the second last, and answer is 2. Okay, how is the answer 2? How can we gain 2 points? How can we gain 2 points there? Yo, Terry Davis. Terry Davis is a amazing guy. Do not say anything bad about him. He was a religious person. And have you seen? Yes, I will get to the question. Have you seen his photo? I mean, you must have seen his photo. He was reporting to a CIA. God song, funny moments, funny moments. Open Internet Explorer. This one, average Linux user. Look at the like this thing. I cannot hover because the video plays. I am King Terry the Terrible. The CIA will be executed. Well, that is amazing. That is only he can do that. King Terry the Terrible. Okay. The first test key. Wait. Alan has an array. He partitions the array into n by k disjoint sets, and Alan earns a point if there exists some positive integer m, such that if he replaces every element in the array with its remainder, then all the subarrays will be identical. So he is building on top of what was. No, he's not building on top of anything. Here the answer should be 2 for 5, for third, 1, 2, 3. Yes, it is 2. And for the second last one, answer is 2. So we are considering the case when we are not dividing the array at all and k equals n, and we are not counting the thing multiple times. So this thing is wrong. This should be 1. And we have this also as an array with k equals 6. Okay. So we just have to find one m which works for any k, and that will earn a point. And here, this thing will always earn a point. So at least we will have 1. But then what can we choose as M? Alan earns 1 point if there exists some positive integer M greater than equal to 2, such that if he replaces every element in the array with its remainder when divided by M, then all subarrays will be identical. So if there is a M which works for this array, then it is going to make this 3 and 1 equal to each other. Okay, so let's be more methodical about this. We have two numbers, A and B, and we need to find some M so that A equals B when we take whole modulus M. This thing has to be true, and we can write this statement as A equals some K1 into M. Yes, A equals some number, let's say X into M plus some value I is the remainder, and B we can write as some value Y into M plus J, and we are saying these remainders I and J are equal to each other. So we can say we want I equal to J, and we need to find M, such a M where I equals J and I is A minus X into M equals B minus Y into M. Okay, and A minus B equals M into bracket X minus Y. We don't know X, we don't know Y, we don't know M. We just know A minus B. Wait, A minus B. If we take modulus of this whole thing, this side will return 0 and this side will return some number. But we have multiple A's and B's. Yeah, that is some technical talk going on. And have you told him, have you told Tech Maniac that you have a very good keyboard? And also your keybind is amazing, by the way. Just saying. A minus B, M into X minus Y. Okay, we don't know M. We know A and B, A and B, what A and B are, and that is like, okay, let's take this example. And when we have an array like this, we will start iterating using the basic formula for finding factors of a given number. We will start iterating I in the range 1 to M, 1 to N, 1 to root N, which we can write as N power 1 by 2, right? In this range. And whenever we see that I, let's say this is not I but K, and this matches with the question. And whenever we see that this K divides N, in that case, let's say in this here, K equals to 1 does divide this answer, and K equals to 2 also divides this answer because N is equal to 10, and K equals 5 also divides this answer. So when k equals 5, let's say, yeah, let's say that k equals 5, we can not physically but spiritually, we can think that this array has been divided into two subarrays of size 5. And how do we know about 5? We know about 5 since k currently being 5 is dividing n, which is 10. So in spirit, we are going to divide this array into two parts. And these A and B are going to correspond with these elements. We are going to iterate now. Okay, that is just too small. We are going to iterate now with these elements. First, these two numbers are going to act as A and B. And our goal would be to find out M, which works with these two. And so yes, this is one method we can do where we will find out a list of m's. We can create a set of m's which works for these 1 and 3's, for this these two elements 1 and 3, and then we can move on to the next element and see which m's work for the 7 and 1, which makes their modulus equal to each other. And then we can move on to the next, and whenever we see a new m, it has to be also capable or compatible with the m's that we have seen in the past. And if the current m, which we have, let's say, to make 4 and 1 equal to each other, their modulus equal to each other, we need some particular m. And when that is the case, we need some particular m. And whatever m we get should also be able to make all the other elements which we have seen till now equal to each other. But if the current m that we see cannot do that, then no, this k is not going to work. And we will move on to the next iteration of k. K, and let's just pick two examples in random. This is our formula. This one is our formula, which is going to help us. Yeah, let's take some values of a and b for which we do know the answer. For making modulus of 1 and 3 equal to each other, the values of m we can choose are greater than equal to 2, is going to be 2, because these two have 1 as remainder when we divide these by 2. And then there is no other value when our m, if these two numbers are not equal and our m is equal to one of the numbers. Our m will not work if we have reached one of the numbers, the bigger number. It is not going to work then. So yes, so 2 is the only m that is going to give the same remainder for both of these numbers. And if we apply this formula, let's not think about the order of a and b, and let's just say first one is a and the second one is b. So this thing will be -2. And shit, if in this equation we take, this is the equation that we have. If here we take mod m on both sides, and we can do that, we can think that this is some number, random number, this is some random number, and we are just taking mod m on both sides. So what we want is a minus b mod m equals m into some number x minus y mod m, and this is a multiple of m, and we don't know about this. So this thing on the right is going to return 0, and this thing is a minus b mod m. So what m is going to return a mod of 0. Whatever we see is the difference of these two numbers. Like in the above case, the difference was -2. For minus, not difference, is, let's say difference, what are the numbers which are factors of 2? Those are the only numbers which will return mod m. Those are the only values of m which will return 0 here, and which just happens to be 2. -2 would also return 0 as a remainder, but that is outside our range. Our range starts from 2 till positive infinity. So we just need to take the positive of this difference. Yes, we will literally take difference. We will say A is the bigger number and B is the smaller number, and we will see what their difference is. Find all the factors which, yes, find all the factors for that number which we can easily find if we do some pre-processing. We can do some pre-processing using, yes, now the time complexity. Yes, we can do some pre-processing which will be able to, through which we will be able to find out these factors. And generally speaking, if we have a number n, it is going to take us root n time complexity to find all the factors for this number. And let's talk about the whole time complexity now. We have in total n numbers, but not just this. This would be the case when A and B are two numbers, but that is not the case. We might have multiple numbers, which we do have multiple numbers. Yes, we do have multiple numbers. Like in this case, we have multiple numbers. We want 1, 1, and 3 to give the same remainder, and we get 2. Okay, this is interesting. This is interesting. Yes, kinesis is, yes, that is the exact same question I asked him. Like, why brown? If you have a kinesis, why brown? Although these days I am liking corn keyboards. You do have a corn keyboard, right? So I don't know till when I will be using kinesis. Wait, your kinesis is a corn, right? If shit, no, no, my bad, my bad. Corn are different keyboards, my bad. Shit. Okay, now we can solve this question if we only have two numbers which we, for which we need to find a number which gives the same modulus, but we might have different multiple numbers, in which case we would have something like A modulus m equals B modulus m equals C modulus m, right? And we can write all three of these as A equals k x into m plus I, right? And for B, we can say B equals y into m plus j. And then for C, we have plus k, x, y, z. And what we want is I equals j equals k. We need to find such a m for which I equals j equals k. And we have three questions, and we have 6 unknowns, 4 unknowns. We don't know x, y, z, and we don't know m, but we don't even want to know x, y, and z. We just want to know m. Let's solve these one by one and we might see some pattern. For when we had two equations, what we found out was A minus B modulus M equals 0. That is what we got when we had only two variables. But now we have three variables. Let's see what we get. Okay, we say that I equals J equals K, right? Yep, that is the basic thing. We want the remainders to be equal to each other. Then we can replace I, J, and K with their respective values, which are A minus X into M. For J, it is B minus Y into M, and then for K, it is C minus Z into. Okay, this is what we have. And can we do something? Let's say we no what let's solve them two at a time. Let's solve A and B first, and we will get, if we solve them two at a time, we will get A minus B modulus M equals 0. And then we solve for B and C, we will get A minus C, B minus C, C minus B, modulus M equals 0. And when we solve these two, we will get C minus A. The order of this subtraction does not actually matter. And since all of these are equal to 0, so M should be a factor of A minus B. M should be a factor of C minus B. M should be a factor of C minus A. And if, okay, so this is going to be very big very soon, because for large numbers of divisions, we will have, here we just have three variables and we already have three equations. What if we had four variables? What if we had D also as a variable, and if we had D also as a variable, we would add three more equations: A with D, B with D, and C with D. And if we add one more variable, E, we would add six more equations, four more equations. Yes, A with B, uh, uh, E, A with E, B with E, C with E, and D with E. That is not good. And we want M to be a multiple of all of those differences. M to be a factor of all of those differences. Can we arrive at a better formula? What if we have, let's use some example. A equals 1 and B equals 3 and C equals 5. Here the only valid value for M is M equals 2. When we take modulus 2 of all of these numbers, we get 1 because all, because yes, that is what we get. Can we do something here? When we do A minus B, we can write it as minus 2 modulus M equals 0. And for C minus B, we can write it again as minus 2. Let's say we are only taking the absolute sum, absolute difference. This also is minus 2, and that is 4 modulus M equals 0. And the only number which we can like directly see, which is making modulus of all of these numbers the smallest is 2, and we will be getting a lot of differences. And the number of pairs is going to be n into n minus 1. And that is a lot of numbers. That is a lot of numbers. Yeah. Slow. Bro is slow at 9095. By the way, yes, what is your practice approach, and also what is the minimum time you think for a person to get good at like what are, wait, 29, 4 minutes. So what are solving learning approach do you think? I would say this is something that I know is like at I'm reaching out my hand to grab something that is too far ahead. So it is okay for me to think about this and spend my time, and I do not have to like regret or think that I'm bad if I'm taking more time at this, because that is natural. So it helps if you do not think about yourself as you are bad and you cannot achieve anything in life. So do not feel bad about yourself if you are unable to solve a question. That is a very important thing. And experimentation, whatever you see, experiment with it and be curious. Like I try to go with the thing that Einstein said. I am uh, yes, I have no special talent. I am only passionately curious. So I'm not curious, passionately curious. That is a very heavy burden, but we can at least try to be passionately curious, and that helps a lot in learning. Try to be passionately curious. Hello, how can I do it? You can just go to this website, CP31, and start solving these from, you can start from these easy questions and get a hang of it. Be more familiar with these and work your way up and keep learning new things along the way whenever you see something new. Yeah, you can start a channel. That is also nice. It, yeah, starting a channel will keep you accountable to some sense. So that is also good. It's something you can do. But yes, you will struggle like right now. Okay, so it is easy to find what is the like modulus, which number gives the same way. This is, by the way, Euclid's theorem. Yes, this is kind of like Euclid's theorem. When we take the difference of two numbers, when we are trying to find their GCD, this is kind of the same thing, right? Okay, you don't know. Yes, nice try. I mean, I cannot say, I cannot judge if you are genuinely curious, genuine. If you are genuinely asking this question, I think you are messing around and you already know how to program. Yeah, I think you are just messing around here. But yes, you are curious, but I think you already know what basics are. I mean, judging from what I have known of you, basics are addition, subtraction, multiplication, division, and modulus. If you are really passionate, yes, bro is really passionate, get into modulus operator. I mean, you can do CS50 if you are genuinely want to learn the basics, CS50. And wait, you don't even need a course. Since you have read Linux Bible, I would say you can go to the C programming language by Brian Kernighan. and Dennis Ritchie, of course, both of them should this book, The C Programming Language by Brian Kernighan and Dennis Ritchie. You can go to this. But this is the old version in 1988. The new one I think came out in around year 2000, but in 1997 or something, second edition. There is also ANSI edition, ANCIEE, ANCC, ANSI, NCC, and yes, piracy at peak. If Raghav modulus 2 equals 0, standard out, hello world. What would be the output of this thing? It is ANSI, yes, ANSI. Oh, so you are using modulus, so you are a passionate guy. Yes, modulus, that is the thing that tells if you are passionate or not. And this is the book. Wait, which year did this come out? And there is no year. This is eternally, this has existed eternally. Yeah, there is no year. This was just always there. Okay, and I just do not want to look at the editorial just yet because I think I'll be able to figure out. And yes, this is the question. And I would please encourage you also to think about this. Shunyazm. Yes, book is timeless. It's existed since the beginning of time. And this book, by the way, is not just good for programming in C. This is just a generally good programming book. This teaches you about what is standard input, standard output, and there is also standard error and how they can be pipelined with each other. Little tricks about Linux or Unix more correctly. Yeah, this is just generally a good book. The time we can take is 3. The mental model that I have with this is something like this. We have a array like this, right? And we have this array has n elements and we are iterating k from 1 till n is also a factor, 1 till root n, and 1 and root n are also included. And whenever k divides n for k equals to 1, or k will divide n, whenever k divides n, we will have two factors. Exactly, k is going to be a factor because it is like directly dividing n, and n divided by k is also going to be a factor because that is the number on the other side. And if at some point root n also divides n, that would only be when n is a square root, like perfect square, like 9, and when k equals 3. In this scenario, the opposite pair with which k has to be multiplied to get up to 9 is k itself, since this number is a perfect square. So in this case, we will not do anything for the opposite pair number. And that was like an implementation detail, not very necessary and while thinking about the problem. So let's say we have some particular k. Let's say k equals 2 is dividing n. And if that is the case, then we are going to divide, or let's say k equals n by 2 is dividing n. In that case, we are going to divide this array into two parts. And when we do that, we will have array size as n by 2. This is n by 2 size, and this remainder is also n by 2. Okay, and we want some m, for which if we take modulus m of all the elements, in both of these segments will become this one, and this one. They will become equal to each other. They will become identical. That is what we want. And if you want that, we want this first element to be equal to this first element in this segment, and this element to be equal to this element, and then third element equal to the third element here, and so on till the last element in the first segment equal to the last element in the second segment. But in this case, it is easier because we only have two segments. In other cases, when n is a smaller number, shit, when k is a smaller number, let's say k equals to 2 is dividing the array. If k equals to 2 is dividing the array, then these segments that we are creating will only have two elements, and we will have a lot of these small segments, and that is hmm, shit. This is crazy. So we will have a lot of segments. We will have a lot of segments when k is a small number, because that is how many elements are going to be in individual segment, and the total size is n. And we want the first element in this segment to be equal to the first element in this, first element in this, first element in all of the segments. When we take modulus of this whole array ai with some particular m, and okay, so let's say there is going to be, let's say, a range, some number of m's, m1, m2, m3, m4, and these are not chips made by Apple. These are numbers. So let's say there are four m's, which by which if we take modulus of this first element and this second element and this first element in the second segment, the numbers that we get by modulus m1, modulo m2, modulo m3, and modulo m4, they will be same. So these four are possible candidates. Yeah, we cannot have anything other than these. These are the only possible candidates. Then we now want a couple of things. First, we take this second element here, this second element here, and this, whatever possible values of m we can take from this, it is whatever possible values of m, whatever possible values of m which are going to make these two second elements equal to each other, they have to be one of these already possible candidates. And so that would be to make two of these segments equal to each other. But then we have to make this segment equal to this segment, and also this segment equal to this segment. And we have to make all these segments equal to each other. And that is a terrible thing to try to do. That is like a lot of work. Yes, it is GNU Linux. Yes, it is. Stallman is very angry. How are you offended by that message? That is the truth, as in like truth social. We want to make these segments equal to each other. Any ideas? let's say we have three segments, right? One, two, and three. And each of these have four elements. One, two, three, four. One, two, three, four. And then one, two, three, four. We have four elements in each segment. And we don't even want to find a particular M in that work. We just want to know if it exists or not. Yes, we want uh and the at the end we want this number to be equal to something. Let's say A. This also should be equal to A, some arbitrary number A. This should be equal to B, and this also, and then this should be equal to C, C, and this should be equal to D, D, and D. And these ABCDs can be any number. We just want them to be equal to each other. And yes, we want these elements to be equal to each other. And whatever M, so first of all, not first of all, we need M has to have a couple of restraints. Let's say there is a range of M which makes these first elements equal to each other, and there is a range of M which makes these other elements also, like which makes B, all of these second elements equal to B, some any random element, and a range of M's which make these C's equal to each other, and a range of M's which makes these D's equal to each other. And we want whatever M we go with, that M should be in the range which is making these A's, in the ranges which are making these B's and C's and D's, because this one M has to work with everything that we have here. GNU, not Unix story. Yes. Yes, that is just a recursive name. Bro is a genius. That is such a good name. Most people won't be able to like comprehend what is the full form of them. The full form of GNU is amazing. Yeah. Mm, like very cool. So we want to find, is there a M which works, which can be there for all of these, which can make all of these equal to each other. Okay, for this question, we have like it is already more than 1 hour, but this is fine. This is fine. Let's say if the clock hits 2 hours, then we will look at the editorial, and I am willing to think about this single question for 1 more hour. And this is lagging. This was like literally lagging. Is the stream also lagging? No, stream is fine. That is cool. It is a hacker tradition to name like that. Shit, hackers. That is nice. I have a book for similar stuff. This one, Hacker's Delight. That is nice. But yep, Hacker's Delight. This is a nice book. Very nice book. And this has binary tricks and tips you can use. So for here we have n equals 10. And the number of keys which are going to work for this is 1, 2, 5, and 10. And for 1, the answer is let's say for each k, we are going to put these segments on top of each other. For k equals 1, we will have 1, 7, 5, 1, 4, 3, 1, 3, 1, 4. This is what we have for k equals 1. And for k equals 2, we have 1, 1, 7, 5, 1, 4, 3, 1, 3, 1, 4. These are the segments put on top of each other. And for k equals 5, we have 1, 7, 5, 1, 4, 3, 1, 3, 1, 4. Right. And for k equals 10, we just have 1, 7, 5, 1, 4, 3, 1, 3, 1, 4. That is the only thing. Yes. For k equals 10. So our goal is going to be, for any particular k, we need to make the numbers in a certain column equal to each other. That is going to be our goal. And I think this is a better way to depict this question instead of what we were doing earlier. So for k equal to 10, we already have all the elements in a column equal to each other because there is only one row. So yes, so we get 1 point for this, like by default. But here, these two are equal, these two are already equal, and these two, we can keep their difference, let's say. The difference for these two elements is 2. The difference for these two elements is 6. The difference for these two elements is 2. The difference for other two is 0. And the difference for the last two is also 0. Well, we can see there is a m value which divides all of these numbers, and that is 2. So if we take modulus of all of these numbers with 2, if we take modulus of this one with 2, we get 1. Here also we get 1. So these two are same. Here we will get 1. Here also we will get 1. Here we get 1, 1, 1, 1, 1, 1, 0, 0. And these two are same. So we do get a point here. That is nice. And this is easy to spot when there are only two rows. But in this case, when there are multiple rows, what do we do? Wait, instead of, okay, the problem that I was facing is I thought we have to pair this with this, with this, with this, with this, and like with all the numbers. But maybe we can just pair up these adjacent numbers and find if there is a number which works for them. Wait, that might actually work. That might actually work. And then whatever, we will create a set of possible m values that are working for all of these numbers. And we will do this. And at the end, we will see the size of this this m set. And if the size of this m set is 0, then we do not increase our score. But if it is 1 or like any positive number, then we do increase our score by 1. We can pair up these. Okay, so now we need some bigger example. We need some bigger example. Which one? Here we have answer 4 for the fourth last. 1, 2, 3, 4. This one answer is 4. But the numbers are not very different. Still, let's see. I think we can do this. We can do this without now visualizing the thing. Let's actually write the code. Random question. What are you planning after DSA? Some web dev, some system dev. After DSA, I want to create like development projects in C++, first of all, to like have more variety and more experience with C++, first of all. And then, yes, developments, on development side, I will be like learning how to do web development is not a like particular thing which I will be doing it, but not as in, okay, now this is the main thing, web development. This is the main thing that I'm doing. I will be doing it, but not as the main thing, because I think web development is just like addition, subtraction. It is like supposed, it is hard in itself. I'm not saying that it is easy, but it is supposed to be like, you know how to build a website if you are anyone. If you are a programmer, you should know how to build a website. So that is going to be the mentality for web development. And besides that, the things that I will be streaming, they are going to be things from build your own X. And there is already a project that I have selected, not a 3D renderer, but uh, this one, database. Build your own Redis from scratch in C++. This is the thing that I will be streaming after DSA next year, and this is going to be cool. But before that, I want to build Conway's Game of Life on my own without looking up anything. Not like, yeah, in a auto on my self research kind of way. That would be good. And after that, I will be following this thing, this book. Build your own Redis on a stream, and this will be fine. Pretty cool. And now let's code. After thinking about this for 1 hour, let's code. Int n and then the array itself. Cool. Int reference x, a, in x, we have all the numbers, and now do we do some pre-processing? We will be needing factors of numbers. Do we use uh, smallest? Do we create the SPFA, smallest prime factor? Yeah, smallest prime factor array, or do we do something else? Okay, if we do create a 3D matrix on 3D, not 3D, but 2D matrix, which is going to contain all the factors for numbers from 1 to n. So at least one dimension. On one dimension, this thing, if we do create a matrix which is going to contain all the numbers which are a factor for a given value of n, one dimension is of course going to be 1 by n, and depends on the other dimension. So n at most, n is the biggest number, and it might be a prime number. So in general, a number n has log n factorials, log n factors in generally speaking. So the space complexity would be n log n, which is fine, and it will actually help us. But to get to this point, how do we create this? Yes, we can use the same sieve method to create this. We can have I, which iterates from 1 to n. Yes, I, which iterates from 1 to n. And in this time, we will do I into 1, then I into 2, and all that till I into some number k, while I into this all of these numbers k is smaller than or equal to n, and whenever we land on a number we will add push I as a factor of that number, and space complexity and time complexity are going to be about n log n, and that should work. So let's do some pre-processing, and we can actually make this a const expression. We can be like very genius and make this thing a const expression. Yo, hello. I just started solving 2000 rated problems. Why is this thing in quotes? From TLE sheets, I can understand the question, but I cannot think of the solution unless I see the code. Bro can help you. Master star. Your message went away. Master the star printing, or it fixes brain wiring because it is a pattern problem. Yeah, you will have to see what the particular problem with you is. Int const int range is 1e5 to e5 to e5, and let's do int. Okay, this can be very tricky. A pointer of pointers. Uh, do we want to do this to save time? I don't think so, because the complexity that comes with this. We can do this. We cannot use a vector in const expression. Expr. Yes, I think we should go with a vector, with a normal vector, and not make this a const expression. Vector, vector, or vector, facts, size, range. Yes, yes, range is okay, and then vector int, and then void fill facts. Does not take in anything. For int I equals 1, I less than equal to. Wait, we don't even have to go full way there. Hmm. We don't have to go full way there. Instead of going till range, can we do square root range? Yes, we can do this. We can do this. We can do this. We can do this. This is okay. This is okay. This is okay. Yes. For int j equals 1, while I into j is smaller than equal to range and j plus plus. And now for the number I into j, we have I and j as two factors of that number. But we will have duplication in our vector. So we can maybe use a set here instead of a vector, because this thing going up till square root is decreasing the time a lot. But do we actually want to decrease the time? I don't think it is worth decreasing the time. It is worth decreasing the time, but already the time complexity is not too much. If we don't go till s cube square root, then the time complexity. With the square root, the time complexity will be uh, square root of n into log n. That is going to be the time complexity. But if we do not go with this, we do normal, we have n log n as the time complexity. That is also fine, because in this approach we are going to have repetitions, because let's say for some value of I we got some j and we appended I and j as factors of I into j, but then we increased I up to a value which earlier talk, which we can fix now like this: j equals I. So j is never smaller than I. It is equal to I and greater than I. And we can do this. Yes, because for all the smaller values of j, we have already I multiplied I by them, because all the smaller values of all the values which are smaller than current I has already passed through those values. So we can do this. We can do this without making the duplications in the facts matrix. That is pretty nice. And the time complexity that we do get is square root n, because this loop goes till square root n times, and this loop on average is going to go log n time. So this is actually pretty cool. Facts I into j dot push back I, and also push back j as the factors. And let's test this for some smaller value of range. Let's say for range equals 20. What do we get for range equals 20? Auto x n fact cout x and switch. We will flush. There's some error. Line 1. Bits range vector facts range int vector int initialize fill facts void int I equals 0, I less than in equal to square root. Don't we have the function square root? Let's we start client D, and there doesn't seem to be any error. There does seems to be some error. Okay, it is working. Int I smaller than range k. Let's see, stop. It does work. And let's like, it is working. This is working. See out for int I equals 0, I less than uh, facts dot size I plus plus. See out I, this thing, and then facts I. Okay. What do we have? We have all of this. For one, we have two factors, one and one, which we can avoid, Okay, we can fix that. And for two, we have two factors, one and two. For three, we have two factors, one and three. For four, we have double factors. We have two twice. For seven, we have everything correct. For six, 1, 6, 2, 3. Yeah, we just have repetition whenever we have a square, which we can fix, easily, or it might be skill issue. Stop using social media. Okay, bro is going hard after him. If I is not equal to j. Now we do not have repetitions. 1, 2, 1, 3, 1, 4, 2, 1, 5, 1, 6, 2, 3, 1, 7, 1, 8, 2, 4, 1, 9, 3, 1, 10, 2, 5. Yeah, everything is cool and there are no repetitions now. That is cool. Okay, let's increase our range to the actual range, which is going to be 2e5 plus 1. And let's see now. That is a lot of numbers. This big number, wait, why do we stop? Okay, we do not stop there. There are a lot more. This is the biggest number. This has 1, 2, 3, 1, 2. That is nice. Yes, that is okay. That is exactly what we need. And there are no repetitions, so that is cool. Okay, so we have our vector, our matrix, to quickly look up factors of a given number, and we are not even taking a lot of time to calculate the matrix. Then we take in our array and we will work with that. It's not hard, come on, it is just me saying stop being distracted. Yes, that is exactly what you are saying, and that is good. Yes, that is like David Goggins thing. That is good. I mean, you read Linux Bible, you can say this. And I, I mean, you also have this, but I also have this. TCP/IP Illustrated Volume 1. Yeah, and you also have this. They don't know me, son. Yes, they don't know you, son. But you are who's going to carry the votes and the logs. Okay. After this, shit, 40 more minutes to do this. We have a, that is nice. We have a matrix in which through which we can quickly look up things, and now we have to implement something like this. I know all the factors of vector int for int k in facts n. For, yes, k is always a factor of n, and k is going to be a size of a subsegment. Yes, and now for particular values of k, we need to find a good m. Let's create a set of integers which we will pos m, as in like possible values of m. And okay, this outer loop is going to run log n times. Yes, and now depends on the log n times, we can at max run the inner loop or let the inner loop take n iterations. Well, yes, it is going to take n iterations because we will go through these pairs, and then for the second elements in the segment, and yeah, it is going to take n iterations. Not, and that is good. That is not bad. That is good. This creating this thing was okay. For int I equals 0, I is smaller than k, I plus plus. For the ith number in a segment, right? Cool. And internally for int j equals 0, j is going to tell us which segment we are currently at. And we will start going from the first segment, but we will not go to the last segment. We will be like reaching out because we will be processing the current segment and the next segment always. And this is a theory only. I don't know if this is going to work, but let's see. How many segments do we have? We have j while j less than n by k. That is how many segments we have. Yeah, and j plus plus. And what are the current numbers? We can say int a, no, int a, no. Int x, we have two numbers, x and y. X is a I j into k plus I, right? That is the first number. And y is a j plus 1 into k plus I. These are the two segments. And we will have to do some change here also because we do not want to go to the last segment. Yes, because we are outreaching. Now we want to find if, okay, because we also need to initialize m to something. Okay, here, here we will initialize this segment, this set of possible m's for the possible values which are going to give us this thing. And that is going to be, let's say, and d equals absolute difference of the first and the second element. First element is a0 minus the second element is going to be the first element in the second segment. It is going to be k, index k, except if k is equal to n. Yes, if k is equal to n, then no. If yes, if k equals n, then we do not have multiple segments. If k is smaller than n, only then do we go in. This is getting a bit complicated, but yes, what's up? Okay, 894. Okay, I will look at it. How to learn DSA, any reference, practice and grasp new concepts. Technically, I have followed this. Yes. But everyone has a different approach to do the stuffs. Yes, yeah, you have to find your own thing, and you can only take inspiration from others. Like, yeah, that is all you can do, and devise your own method for learning. And yes, this is the question that we are doing. This is 1600 rated, way outside my current league. Let's do this. Here, when we have a D, what we will do is shit. Yes, we can use a shorthand here if you want. Um, fact of D dot begin and facts of D dot end to get all the factors of D as the initial values in this set, and we will remove 1 because we cannot have m equal to 1. Dot remove 1. Erase, yeah, erase 1. Now m is set, and we need to find possible values of m for this. Okay. Bool then equals false. Bool done equals false, and no. We will have this not here but here, a global level. Bool done equals false initially, and no shit. We need the count. We need the for a particular value of k. We need a count. Yes. Okay. Int answer equals at least 1. Answer is always going to be at least 1. Again, we will output the answer. Okay, and for every value of k, we will have bool then equals true, and if, which will be inside here, or we can say answer initially is equal to NC partition array, not the binary that is. If then answer like that. 17, and we can say control X. The answer starts at 0. And for a particular value of k, if answer is true, then true. Right, and internally we will update the value. All right. Yes. Okay. Okay. Now we have a particular value of x and y found, let's say, equals false. And okay, so we don't even need this. We will be taking intersection. Okay. Intersection. We have a set and a bunch of vectors, and we have to keep taking intersections. How do we do that? How do we? Shit. If we are going to take intersections, it would be much better if we are internally here using a set instead of a vector. I'm currently thinking about giving it a try in military. Recently, I just want to try something, some new guns or grenades. It is cool. You live in Texas. I think that is trying some guns is the natural response of someone who lives in Texas. So I think you also must have some guns at your house. You can use them. And do you know about FPS Russia? He is an American who has a lot of guns and he got into police trouble, like FBI open up kind of trouble. You can try some guns. Like, getting into military because I want to try some guns. That is cool. So now we need to take union, not union, intersection of two sets, and we can iterate through the first set. And if we see that this element is also in the second set, we keep this. If it is not in the second set, we remove this. And this would be much better if both the things are sets. So let's do that. Set, set. This is a set, and this is also a set. And not a push back, but insert. And we can do this, just do this. We will always have different things. Insert. Okay, we have to change that second pushback to insert. This is fine. We can do this. This is fine. We can do this. Yes, and this is also fine. We can absolutely do this. Yes, all of this is fine. Now, we need to check for the current I and J. At least, okay, both of them cannot be equal to 0. At least one of them has to be some non-zero number. That is why we are checking I and J. That is nice. And after that, we will iterate through the current set, this pos M, and the second set also. How to take union? Can I'm inspired by a character in Delta Force. You can search in Google. Subrosa. If I get into military, I wanna wear that character. Okay, I have 3 rifles and a handgun. Very Texas thing to say. My grandfather is a veteran, so he does have a couple. Yeah, 3 rifles and a handgun. Subrosa. Under the nose. Subrosa in Latin means under the rose, used as an adverb to describe something done secretly, confidently, or privately. The term stems from the ancient symbolic use of rose as a token of silence and secrecy, and a tradition dating back to Roman times when roses were used in banquets to remind guests that their conversation should be confidential. Okay, so confidential, it should be confidential, private, and secret, not publicizing it in YouTube chat, I guess. Or, wait, Subrosa is a character. Neo Latin under the rose. Okay. Yeah, I'm not looking at the thing that you are referring to. Like I'm unable to. Look at that. And this is nice. Okay, now we need to take some sets. ChatGPT. Can I remove elements from a set in C++ while I am iterating through it? It is a associative set. You can remove element while iterating, but you need to be careful because erasing an element invalidates that iterator. But I'm moving on to the next iterator. In associative containers, only the iterator to be erased element is invalidated. All other iterators remain valid. That is cool. That means you must move your iterator forward before erasing, otherwise you will be left with a dangling iterator. Safe ensure while safe erasure. While doing this, okay, we will be updating on our own. That is cool. Okay, for auto IT equals pos m dot begin while IT is not equal to pos m dot end, and this we will update on our own. If the number in IT does not exist in facts, absolute difference, absolute difference between x and y, d dot count or find or anything, uh, dot count or has, how do we take if a number is in a set? It's like this, dot count d. No, no, not d, but go to it, whatever is the value at. If this current it value can be used in both of these sets, then okay, then it plus plus. Else, auto, and next is it plus 1, or or since this is an associative container, so auto next is it, and it pos m dot erase it, and it equals next. Or we can do, yeah, this is fine, this is fine. Erase, no, shit, we can do erase next. Before that, it plus plus. It is now on the next one, and we have also erased whatever at it was. So after we have gone through all of this, if pos dot m dot size, if possible m, there are still some remaining possible values of m that we can choose, then okay. But if pos m is false, if we don't have any possible values of m, then m equals false, and we will break out of this. And if not, done, or wait, done is not the one that we are, done is the one that we are using here. If not done here, then break. Okay, this is getting there are a lot of things here. Okay, I think we are done. I think we are actually done. Think we are done. This should work. The time complexity does look amazing. Like, what is this? Nestation. Okay, run. And wrong answer is what we get. We always output 1, and that is not good. That is not good. Mm, let's always output the value of the sets. How is the set changing after each value of x and y that we are choosing? Right, okay. For int x n possible values of m, see out x with some space. Yeah. And see out some percent new line to indicate this has ended. God. Let's go with a small example like this. Yeah, this one is fine. 1, 2, 1, 4. We have only one test case which has 4 elements 1, 2, 1, 4. Empty. The set is empty. Did it have any elements to begin with? Yes, did it have any elements to begin with? We have only one test case which has 4 elements 1, 2, 1, 4. And it did not. Sadly, no. Was empty. Why? A was M was empty is for set of integers reference x and facts for end I n x see out I space and see out a new line and also flush. We should see a lot of things, hopefully, but we do see a lot of things. That is good. That is good. That is very good. Let's have a set of integers s for the factors of number 20. Facts of 20 begin and facts of 20 end. And we will print this set for integer x and s. See out x with a space. See out new line. We do see factors of 20. So Shit. If A is not equal to B, then shit. Okay, if D is 0, then we can skip this particular D. Yeah, we can then just skip this particular D. How do we represent a infinite set? How do we represent a infinite set? A set that has all the possible values of n, I think, by using something. Hello, happy to share. You two may be blocking my message. Shit, what are you sending? Are you sending some crazy things? Memes and respect. Bro, how much time has it been learning DSA? About 4 months, less than four. Yeah, four. This is 93rd or fourth stream. Yeah, and that is how much time it has been. Pause m dot erase one. Okay, we can have a variable which will tell us, right, is the stream, no, stream is fine. Subrosa delta force. Wait, that is what you want to wear. That is a nice gear. Look at this. Subrosa delta force. Delta force is I so delta force game on X. So delta force is a game and Subrosa is a player. Yeah, okay, yes, you did say Subrosa is a character. Okay, so this is the character. He does have nice gear and the mask to add on top of it. Miss Doctor Doom mask. That is nice. You can go with that. Bool infinite set equals not D, not D. If D is 0, then infinite set is going to be true. And if D is some particular number, then infinite set will be false. Yes. Now, what do we do after that? Uh, yeah, we erase one, but it was never there to begin with. So for here, if not D, if D and infinite. If our set is infinite and D, then we will do pause m dot assign facts D dot begin and facts D dot end. I want to get this question right, and this will be 5. Yes. Okay. This is true. There are 4 possible combinations for D and not 7 and D and infinite. D can be 0. If D is 0, then we just skip. We continue and move on to the next iteration. So if not D, then whatever the case, we continue and we move on to the next iteration. If D is false, yeah, yeah, that is true if D is 0. But if D is 1, yes, if D is 1, depending on the value of infinity, this state, if infinite is true, then we update pos m to have some value. But if infinite is not true, then we take their intersection. And here we will not print out this. We will not print out this. Where are we changing the value of done? After checking here, not size, we were checking size. We have done there above. Wait, what? Why do we have this here? If not size, that is not good. Yes, we have to have this after checking for the current elements, like here. For the current values of I and j, if the size of done is 0 and not infinity, if the size of possible values of m is 0 and the set is also not infinite, then we do this. And also we have to update infinity here. After this, yeah, if done is false, then n equals 0, not infinity anymore. Yes, not infinity anymore. And now let's see. Pos dot assign. This is wrong. No member assigned for a set. Okay, I think we can use a copy constructor or not a move constructor. That is not good. Pos, not pod. Pos m equals facts d. That did take a lot of time and we did get wrong answer, but this is very good. This is like much better than before. 1, 2, 1, 1. We are getting just 1 here. 1 only because of that. Must be infinity in the first case, and for difference of 2, we do have 1 and 2 as the factors, and yes, this should have worked. This should have worked. Let's output after this for or output infinity, let's say, and for int x in pos m cout x with a new line, that is, and we will output a new thing. Yeah, this inspired me to join military. Very childish thought. Yeah, but that is, yeah, it is childish. It is childish getting into military after looking at a character, but that is how, like, I guess innovations happen, and this should not be a new line. This should be something like this. Anything except a new line would be good. Now, we only have one test case which has four numbers: 1, 2, 1, 4. 0, 0, 1. Okay. What is the original value for infinity? We have one test case which has four elements: 1, 2, 1, 4. Our set did have a value equal to 1, but why was infinity? Okay, what are the values of k then? We have a one test case which has four elements: 1, 2, 1, 4. Okay, k equals 1 and k equals 2. That is good. For k equals 1, we go to 1 and 2. The difference is 1, so infinity is 0. Makes, does not make total sense. Okay, yes, that is true. That is true. Yes, for k equals to 1, the answer is going to be 0. Yes, makes sense. But for here, k equals to 2, initially it was equal to infinity, but it, like, it got revoked somehow. For, let's analyze what happened. For k equals to 2, I equals 0, and bear in mind that n equals 2. Sorry, n equals 4 in this case. So for I equals 0, j equals 0, and this thing would be 4 by 2, 2, 1. J represents, yes, this is good. This is good. This is the only value of j that we will be concerned with. That is good. And here, either I equals 1 or j equals 1. None of them are 1. So we skipped this iteration. and then we go to the next iteration where 1 4 1 4 we have 1 4 1 4. Yes, okay. We go to the next iteration when I equals 1 and 1 is lower than 2, which is k. And now we go I equals 1 and j equals 0. Here I equals to 1, so this is true. We go inside x equals 0 into k, so 0 plus 1, the first element. So x becomes equal to 2 and y becomes equal to the next element j plus 1, and j is 0, j plus 1 1 1 into 2 2 plus I 1, so 3, and the third element in the array is 0 1 2 3 4. Okay, so we have y equals to 4. D should be equal to 2, and if not D, then continue, right? We do not continue. We instead D is not equal to 0, so we do not continue. We go through the iteration and we make infinity equals to false. And if infinity, that is a good thing. Infinity will be changed later. All right, so this should be better. This should actually might work. Delete, delete. For one test case with 4 elements, 1 2 1 4. Answer is 2, which actually is the correct answer. Okay, okay. Answer correct. Answer accepted. That is good. 2 people are witness. This is good. This is good. This is good. This is good. We got the right answer. This is good. And the time complexity seems to be very high, though. The time complexity does seem to be very high, even though we do not have a very big n. Let's calculate the time complexity. K is going to go about log n times, and then we have this and this loop. These two loops combinedly go only n times. So right now the time complexity is n log n. But then internally we have this optional loop, which is itself going to log n times. So log n into log n square, which is fine, which is not very big, which is like 2 log n. Log n into log n square, that's like 2 log n. So 2 log n, that is the time complexity, and the total time limit is 3 seconds. So this might actually work. Let's see. Let's see if we can one shot this. It would be amazing. Yes, one shot. It has already been 2 hours spent on a single question. And after this, we will just look at the editorial. If this works, it is going to be cool. Very cool. Okay, something wrong with code forces. Last submission by the assignment. Those who are with us, last unsolved. And tomorrow is a contest, and this is taking a lot of time. I think there might be, and this might just be running and taking a lot of time in running or some other problem. Unexpected error. What is supposed to be an unexpected error? Uh, Submit. Unexpected error. Okay, let's submit again. Copy. Wait, how many lines is this? 80 lines. 80 lines is fine. Submit. Okay, work. This is just not submitting. Time 2 hours. Partitioning the array. This thing is good. Yes, this is good. And the time complexity for this is root square root n log n. And that is good. Unexpected error again. So let's select the file and upload the file and do that. But here, CSES competitive programming 1600 related questions, partitioning the array, not partition. Is the code like too bad that code force is not accepting the code? That is a possible explanation. After this, we will just go to the editorial and see what the actual thing is, because yeah, because that makes sense. What is the question? This was revision 2 and the question array repetition. This was question C. This was just question C in a division 2 contest. Unexpected error. Okay, so this is not working somehow. Let's look at the solution. Try to solve the problem just for two integers x and y. Under what m are they equal modulo m? Yes, we do know this. We have done our research, like we have done our here and derivations. We do know for two numbers x and for two numbers x and y, if we want to find some number m so that x modulo equals y modulo, we just do x minus y absolute value. We just need to find factors of this thing. All the factors of this thing are going to give us the same remainder. Try to solve the problem. Yes, we have solved the problem for two variables. Then how can we use the previous hint and shit, instead of all that set things that we were messing up with, we don't have to do that. GCD and GCD. If you have numbers 1, 3, 5, 7, 9, the only m that is going to work for this is going to be 2, right? So we can go pair by pair, take the difference here, which is 2. Now let's not do that because this is very simple. Let's take 17. Yeah, only take odd. Let's solve for a more complicated m. Let's say m equals to 4 is going to work for some sequence of numbers, and those numbers can be 1, 5, 17, 21 is also a viable choice, and yeah, there are a lot of choices. 41, right? And if we go pair by pair and we take the GCD, let's say we have the sequence begins with 17. Here the difference is 16, and initially we will say m equals 0. Now we take modulus of m and 16, this current difference of these two numbers, and that is going to be 16, right? Then we go on to this pair and the difference is 4 and our m was equal to 16. We take the GCD now, it becomes 4, m becomes 4. And then we go on to this pair, the difference is 12. GCD of 12 and 4 is 4, so m remains 4. And here also the difference is 24 and GCD of 24 and 4 is 4, m equals 4, and it does work. Ah, shit. Okay, yes, we can do this. We don't have to do all of this stupid thing. This was stupid. Shit. Yes, this seems to be very stupid. Shit. Okay. All this code that I had written, that was very, very stupid. C in n and vector int a size n for int reference x in a, c in x. Yes. Okay. Now is the fun part. For int k equals 1, and we will also have answer equals 0 here. Yeah, k less than equal to square root of n and k plus plus. Okay, if k divides n, if no remainder when k divides, when n divided by k, then we have two values of k for which we have to work with. Yes, okay. Now for int I equals 0, I less than k, I plus plus, and for int j equals 0, j less than n divided by k minus 1 and j plus plus. J is going to be the index of the segment in which we are segmenting into. M initially is equal to 0. Aha. Yes, m is initially equal to 0. That just means infinite. And m equals GCD of m comma absolute difference of a j into, let's make it more readable, more human readable, a into j into k plus I, and the other number y is a into j plus 1 into k plus I, and m equals GCD of m comma absolute difference of x minus y. Factors. Okay, yes, okay, yes, this is cool, this is cool, this is cool. Okay, if m greater than 1, answer plus plus. Now, if k is not equal to n divided by k, then int k dash yeah, k dash equals n by k, and we will do this the same thing with that. M equals 0. But instead of k, we go with, let's call this ko, as in like other k. Substitute k with ko on the whole line. And at the end of this, if m greater than 1, answer plus plus. Okay, 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 okay. That is wrong answer. That is absolutely wrong. It is always, no, not always one less than, but yeah, kind of always one less than the actual answer. If k equals 1, uh, uh, and does not divide, k does divide n, then we will see for the current k, and then we will see for the opposite ko. GCD of m and absolute value of m. If m greater than 1, okay, this is like the correct approach, but we have not done the implementation correctly, and that is the only bad thing. We have not implemented this thing correctly, and it has been 2 hours and 23 minutes on a single question, but that is completely fine. Ko equals n by k, and k goes up till square root of n, and that is pretty cool. Okay, so what is the mistake? Let's output n. See out m for some value of a, and the same thing here. We have one test case which has 4 numbers, 1, 2, 1, 4, and for, but we are not doing anything for the opposite side. For, yeah, we are not doing, why do we output 0, 1? Why are we saying 0, 1? Why was k equal to 1 twice? For n, okay, for n equal to 4, n equals to 4. If uh if m greater than 1, or not m, if m is 0 or greater than 1. Okay, that is much better than before. Here answer is 1, but we are saying 0, and that is okay. You should never have an answer equal to 0. And we can never have answer equal to 0. Why are we saying 0 in the last case? N equals 1. N equals 1, so k equals 1 does go in square root of 1 is 1. And when we divide 1 with 1, we get a remainder of 0. M initially was equal to 0. And yes, we have to do the same thing here. If not M or M greater than 1. Only one of these works. And okay, we are getting the correct answer. Let's submit this and see if it actually is correct. Wait, why is the problem number gone? First problem here. Submit. Okay, cool. Okay, this time it is actually submitting. in queue and I think this will be correct. And while this is going through the queue, we can rewrite the whole code. Let's do that. 9 int n, take in n, we will create our vector a of size n, then we will fill our vector int reference x in a, c into x, and for possible values of k, we will iterate through all the possible values of k. K is starting from 1, k is smaller than equal to square root of n and k plus plus. If the current value of k is a divisor of n, then we will do something. And also we have answer equals 0. And let's see, it is still in queue. So okay. And here m, we start with m equals 0, and we will now iterate for int I equals 0, I less than k, and I plus plus. And what is this I? Since our main goal is to divide this array A into segments, and now when a k is valid, we are going to divide these n elements into segments of size k, and I is pointing to some particular element in a segment. That is why I goes from 0 till k. It is pointing to which element in a segment are we pointing to, and int j equals 0, j less than n divided by k minus 1, j plus plus. And what is j pointing to? J is pointing to the segment that we are going through right now, right? So I is pointing to a particular element in a segment, and j is telling us which segment are we at currently. And since we are going to go through the current segment and j plus 1 the next segment, and in total there are n divided by k segments, because each size of each segment is k, we will not go to the last segment because that is like, this is still in queue. That is like absolutely crazy, literally. Right, so j is just pointing to the segment that we are at, and with that we will have two values. The current value, which we are representing with x, we can say a j into k plus I, that is the current value, and int y is the next value in this representation that we were using earlier. This one, x is this value and y is this next value, and this thing cannot go to the last element because there is no y later, right? X is the current value, y is the next value. X will never go to this last row because there is no next row. That is why j only goes till n divided by k minus 1. Now, so what is y? Y is j plus 1 into k plus I. And that is nice. And we say m equals GCD of m comma absolute difference of x minus y. Now, after that, after we have gone through all of the numbers, yes, after we have gone through all of the numbers, we see if either not m, if m is equal to 0 or m is greater than 1, in any case, we can increment our answer plus plus. Now, since k is a possible divisor of m, there is also going to be another number n divided by k, a possible candidate for a answer, but that would only be the case if k is not equal to n by k. That is, k is not, that is, k is not perfect square root of m, of n. And if that is the case, then we will process the other counterpart of this number. And for that, we will do these exact same thing for the opposite k. But we will have to make a few changes. We have to take n, let's say ko, as in other k equals n divided by k, and in this whole thing we will substitute k with ko, and that is nice. And we don't have to use two separate variables, we can just use this. And at the end, see out answer. Okay, it does work. It does work, but on code forces, this is still in queue somehow. Like it is like just in queue somehow. Wait. Uh, 10 likes. That is nice. Cool. And this is in queue. That why is that happening? If we go to status, status, everything is in queue. These are all the submissions all around the world which have been happening like currently in this current moment. And yeah, these are all the people who are submitting, and this is totally a random name. Random people are submitting code, and code forces is down, and this is not working. This is not working. So I think we can consider this question done after an effort for 2.5 hours. I think that, yeah, this probably is correct at this point. 2 hour and 30 minutes. Save. And do we move on to the next question? Yes, we do move on to the next question. At least let's see if we can get on to the next question. And this is, yeah, and you still. And yeah, let's also look at the e- complete editorial because we only saw the hints in the editorial. But how can we use the previous hint and GCD to solve the problem? We can start with m equals 0, and we can keep taking GCD of the like adjacent elements. For some x and y, let's try to find m such that modulus equal to each other. We can rearrange the equation into this form, this which is exactly what we did. Thus, m is a factor of the difference of x and y. Then x and y become equal modulo m. Yes, let's solve for k. For some k, yes, a valid partition exists if there is some m greater than 1 such that the following is true. Yes. And yes, we are just going to take the adjacent elements. The first condition, yeah, we are not pairing everything up. We are just taking the, we are pairing things up here. Uh, First element and the next element in the next segment, the first element in the next segment, and then the second element here and the second element in the next segment. So okay, we are considering two segments here. Yeah, we are considering two segments here. The first condition, this mod is satisfied if m is a factor of these two. The second is satisfied if m is a factor of these two, and so on. So m has to be a factor of all of these differences. Thus, all conditions are satisfied if m is a factor of all of these numbers. In other words, all conditions are satisfied if m is a GCD of these numbers. So a valid m exists for some k if the aforementioned GCD is greater than 1 or equal to 0. We can iterate over all possible k. Remember, k is a divisor of n, and solve for each k to get our answer. The time complexity of this will be n plus log n into maximum divisors of n. Note that each pass through the array takes n log n time, because n plus log n time, because of how the GCD will either be halved or stay the same at each point. That's nice. That actually is nice. And how is the status? It is still in queue. Yeah. Okay, don't get this part. Why is the time complexity n plus log nm? And can we do something better here instead of this? No, this is what we need. This is what we need. Yeah, both we need. This is what we need. This is what we need. Yes, this is exactly what we need, and this should be correct. This should be correct, and we can move on to the next question. Good triples. And the last question was good. Last question was good. This question was good. GCD was the thing that we had to keep in mind, and these questions are getting hard. How would I have been able to find the answer to this question? Yet I should have been able to figure out the GCD part. Yeah, that is bad. That is bad. I was unable to figure out the GCD part. I should have been able to figure out the GCD part. If I had just known that we have to take GCD, I would have done this in like 30 minutes. Yeah, 30 minutes or at max 1 hour. Yes, I do have the state of the whole question, and I can write the whole like code to solve it in 5 to 10 minutes. But I had to look at the editorial, and this was not even using a new concept that I didn't know about. So that is bad. That is not very good. Okay, let's let's move on to the next question then. And how is the status? It is still in queue. All right. Start the stopwatch. We might be able to do this or might not be able to. Given a non-negative integer n greater than equal to 0, non-negative, let's say a triple of non-negative integers a, b, c is good if they add up to n, and a, b, c are non-negative, and digit sum of a plus digit sum of b plus digit sum of d equals digit sum of n, where digit sum is the sum of digits of numbers x, y, and z. For example, if 26, then the pair 4 plus 12 plus 10 is good, and one of them can be equal to 0. Two of them can be equal to 0, and the one can be equal to n itself, where digit sum is. So we have to find out how many a, b, and c are possible. For example, if n equals to this, then this is good because triple ABC is good. Okay. 2 plus 6 is 8, and 4 plus 1 plus 2 plus 1 is also equal to 8. And if we do add 4 plus 1 plus 2, 4 plus 12, 16, 16 plus 10, 26, that is equal to 26. Your task is to find the number of good pairs for a given n. The order of the numbers in a triple matters. For example, this and this are two different triples. Okay, and n is full-blown big number. Okay, I think we might be able to do this. Before that, I will have to go to the washroom, and I will be right back in a minute. Yep. Yo. Me back. There are like exactly 2% watching. That is pretty cool. Okay, this is still in queue, and we need to solve a new question now. Let's go with it. How can we even go about approaching this question? So for n equals 26, we would like to break this down. Yes, we would like to break this down. We can write this as 20 plus 6, and we can take c equals 0, so that is obviously a correct pair. 20 plus 6 plus 0. Yes. So whatever n is, we can treat it as something like this. Yeah, if yes, we can treat n as a array of digits 2, 6, whose size is at least 3. And we can have 2 pointers. Yes. Everything in this range is one number. This number is 1. This number is one number. Yes. These numbers are different numbers. And how can we remove things? Wait, this is like dynamic programming. This is like dynamic programming. This does feel like dynamic programming. Let's choose a bigger n for like 1, 2, 123. This is our n. And what is a choice I can make? I can choose A, B, and C, right? I have to choose three elements. Let's say I am choosing a particular C. If I am choosing, since my number is 123, yes, this is my number. Since my number is 123, all the choices of C which I can go with are 1. Yes, 1. If I go with 1, then answer would be 1. I need to find how many ways can this number be divided into A and B. Good, let's take a small number which has a small answer. First number, 12. It has 9 possible pairs of A and B. Let's go with something other than that. 0 has 3 pairs. Huh? In the first example, these are all the pairs in which we can divide 12. Okay, let's actually go with it. I think we will be able to solve this using dynamic programming. Bit. Okay, yes, we got this. We got this. We got this. We can do this. We can do this. Right. Let's only look at one of these. Since n equals 12, and we have choices for A, B, and C, and we can have a vector 1, 2, 3. 1, 2, 3, and wait. So these A, B, B, and C. These are like very small. We have an a B, and a C. Okay. And we have possible values of n that we can choose. 1, and these values range from 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. Let's say we do not have multiple things. Yeah. Let's say answer for here is 1, which it is, because when n equals 1 and we can only choose one number, then answer is going to be 1. And when n equals 1 and we have to choose two numbers, number of choice now becomes, number of possibilities now becomes 2. Yes, and when we have 3 choices, then answer becomes 3. Yes, answer becomes 3 because we have only one and that one can be equal to A, equal to B, or equal to C. Now, when n equals 2 and we have only one number to represent it. Okay, when we only have one number, then the answer always is going to be equal to 1. So here we can just copy paste this. Always the answer is going to be 1 in at this side, because A must be equal to 1. But when we have two numbers, let's say one choice, two choice, three choice. When we have two numbers and n equals this, then what are the possible values of n? We could have b could be equal to 0, in which case, yeah, b, this second number, since n is 2, second number can be 0, 1 and 2. When the second number is 0, then the first. Now, how do we see what the first number has to be? The first number has to be the second number minus 1. So, this n current value minus the second value. But not just that, we have to iterate in terms of the digits. Yes. No, it is more complicated than that. Yeah, it is more complicated than that. Let's see. Actually see. And this does feel like dynamic programming. Okay, this question is still in queue somehow. Which question? The second one. It feels similar to secret number problem. In the context, you got a lot of minus. I means it feels similar to the secret number problem. In the contest, you got a lot of minus. What do you, when only one digit, then answer 1. If two digit, then 2 combination, and if three or more combo, I guess. Here we have to see how can a number, yes, the second question, this is the question right now. And depending on this, we have to make our choice. Now, the only thing that remains is a efficient way to make the choices. Should n equals 7. Should we can pre-compute all the answers? Yeah, we can pre-compute all the answers. Yes, we can pre-compute all the answers, and whenever we get a n, we can just output the answer. That is something we can take from this. We just have to figure out how we can make a choice. Okay, let's say when n equals 2, when n let's first fill this table manually, thinking about this manually. So when n equals 2, the possible values that the second variable can take is 0, 1 and 2. When it takes 0, the first one has to be 1, and there is only one possibility where that works. And when we have gone with 1, this one, the first one has to be equal to 1, and the, okay, so there also has to be a, like, a row for 0, which would have 1 1 1. Yeah, 1 1 1 as the answer. That would be our initialization, and this row is also our initialization. So when we have two variables, and when this second number b equals 2, the first one has to be 0, 1. So here the answer should be 3. answer should be 3 here. And when we have 3 numbers, for the third number, let's say C can have a value of 0, 1 or 2 up till n, right? And when C equals 0, there are 3 possibilities for n equals to 2. So answer uh, for C equals 0, there are 3 possibilities. For C equals 1, there are 2 possibilities, and for C equals 3, there is only 1 possibility. And is this correct? Is this like are there like literally 6 possibilities for n equals to 2? I think there might be. For we have 0, 0, 2, 0, 1, 1, or let's go with 2 possibilities of 2. 0, 2, 0 is 1 possibility, and 2, 0, 0 is 1 possibility. 3 possibilities like this, and 3 possibilities where we can switch the position of this 0. So this much is correct, at least this much is correct. Wait, this is, so why is the answer for, okay, answer for 11 is 9, answer for 1 is 0 somehow. Answer for 0 is 1. That does make sense. Answer for 2 is 3, for 3 it is 6, and for 4, from our graph, if we go till 4, here the value is 6. Let's make the marker a little bit thicker. Yes, and here the value should be 4 here, and 10. No, I messed up. This shit. I messed up a little bit. I messed up a little bit. For n equals 3, here the value should be 4. Yeah, it does turn out to be 10 for n equals 3. For n equals 3. For n equals 0, we have 1. This is 2, and this is 3. For 2, n equals 2, answer is 3. How is the answer 3? 0 is 1 and 1 is 3. 3 is 10. Yeah. 0 is 1, that makes sense. 1 is 3 because that 1 can go anywhere, right? Third value, 1 is 3. Yes, makes sense. And then 2 is 6 and 3 is 10. 3 is 10. And then 4 should be 15. There is a pattern. There is a pattern. Should that is just so okay. So for our solution, we now have a recursive formula, right? We do have a recursive formula, and now let's write. Okay, we can do this using induction. We can prove. This is good. This is good. This is good. So how do we define our state of dp? Let's say f takes in value of n, and c is the number of numbers abc that we are using. Okay, and this thing we are saying, this thing depends, or this thing is the sum for uh, summation I equals 0 till n. Shit, no. No, 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 no. This was only the case. In this case, nah, sure. Okay, yes. The choices that we are making here, Yeah, shit. Hello. Shit, you have been here before. From Uzbekistan, from Tashkent, I suppose. It follows sum of n numbers, but only up till n equals 10 and not before that. Yeah, it is not working. I submitted a thing. It is in queue. Code Forces has been, I guess, bomb blasted. Status, look at this. All the people who are submitting, all of their things are in queue. Everything is in queue. If you go to like the 5th page, just a moment. They want to see if I am human or not. Captcha. Even in the 5th page, everything is in queue. Yeah, so something bad is there. And what is PyPy? Why is someone using PyPy compiler? Or not compiler, but yeah. GNU C11, someone is like submitting code in C++11. That is a newbie. Yeah, it is down. It is down. Not working. It will work after some time. It happens sometimes. Yes, it should happen. Okay. Yes. So this is wrong. This is not going to work. Think about this is only going to work up till n equals 9. But after that, let's say n equals 10, right? For n equals 10, I can either, and I am choosing, let's say, the third element. When I am choosing the third element, I can iterate its value from like 0 till this guy till the maximum in this thing. It's like C can only have a couple of values, and that is 0 and 1 0. Those are the only values that C can have. Yes. So yeah, the number of choices that we are going to make is different. Yeah, so we cannot have, I think, a direct closed form formula. Maybe code force submission is not working correctly. Yeah, I mean, I don't know, something is happening with it. It hasn't been this down for this long. This is the first time that code forces has been down for this long. And in the spare time, we can just look at the question. We can theorize. So the number of choices, if n equals, let's say, 3, 4, 5, 6, and we are going to choose this third number, the number of choices is a lot. In this recursive function, r, let's write down the, okay, for a smaller value of n, for n equals 56, let's say for n equals 56, our third variable c can have only a couple of values, and they are from 0 till 6, all the values from 0 till 6, then all the values ranging from 10, then 20, then 30, then 40, and then 50, and also a combination of these values like 0, combination of these two values. For 1 here, we can have 1 here, and all these values here. Okay, n equals 56, our c can be, for let's say this thing can range from 1 0 1 2 3 4 5, and this other thing can range from 0 1 2 3 4 5 6, and this thing has a like power of 10, and here answer would be 0, here 1 0 2 0 3 0 4050. These are all the possible values that C can take. And here 0102, which is just 3, 4, 5, 6. And here we can have 11, 12, 13, 14, 15, 16, and 21. Yes, just the same thing till 56. These are all the possible values C can take. And if we are seeing that N can have up to 10 digits in itself, and let's say each of those digits is maxed out equal to 9, then the number of possibilities is going to be 9 power 7, because each digit can take up to 7 values, and this is horrible. We do not want to go through this many choices. Bit mask? No. Hello. One is not working correctly. Yep, C++. Code Forces. Why don't they improve the UI of Code Forces? It is already goated. This is goated UI. Happy to watch you grow day by day. Thank you. Let's go, buddy. Yes, let's go. So my current rating is less than 800. According to you, shall I solve A, B of every contest with this? Can I reach people in 3 months? You can reach people in 3 months. That is not very difficult. We can try to calculate for 12, like we know is the 10. It is 3, and for 11, for 9. So maybe we get some pattern after 9. Yes, we might get some pattern after 9. We'll see. Yes, you can reach people in 3 months, and like the difficulty of contests are different. In division 4, A and B are very easy, very easy. And for division 1 and 2, A and B are very hard. So maybe not 1 and 2 for all the questions. For looking up at questions, you can do this. You can go to this sheet and see easier questions. Get in the flow of solving questions and then solve questions. I Why don't I trust your keybind? I do trust your keybind. It is like pretty amazing. Like look at this. Here when we have four numbers, 1, 2, 1, 4, and the answer should be 2. Answer is 2. Yes, your keybind is working correctly. Okay, so the number of choices is a lot. I'm not manually putting in the command in the terminal. I'm not. Who is putting in the command manually? I was at some point. Yeah, I wanted to see this error. Yeah, I'm not putting in the command manually. So the number of choices is a lot. Can we get this faster? Maybe we can have some sort of prefix. That would be nice. This question is similar to a CSES question. Counting numbers. I think this is the one. And your task is to count the number of integers between A and B where no two adjacent integers are same. Here also we have to do something similar. Yeah, these two questions are similar, at least in the sense that the choices that we get at each dynamic programming step, the process for choosing those things is similar. And this is still not working. And tomorrow is a contest. Cool. Okay, okay. That was, by the way, kind of eureka when we saw there is a pattern here, just n into n plus 1 by 2, kind of something like this. And that was good. But no, it only like applies till until 9. Maybe if we change our dp state, instead, let's have shit. Okay, n can have at maximum 7 values, right? Yes. So let's have something like this. Yes. N can have in at maximum 7 integers, 7 digits. 1, 2, 3, 1, 2, and 3. Right? Let's say it can have 7 digits. Let's solve for 2 digits first. We will go like a small to big. 2 digits, right? Or 2 digits. This is the second digit. This is the second digit. This is the first digit. And here every digit can have a value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this should have answer for n beginning from 0 till like 99. Yes. For 0, 0. Let's switch these up. Yeah, that would make more sense. 0 and 1. I think this is the right way to think about this dynamic programming. Okay, if, and we are going to go digit by digit. So this cell corresponds to 0. This cell here corresponds to 10. This cell, this is, let's solve for a few first cells. Okay, this cell is 0, complete 0. This cell is also 0 because, yes, this cell is also 0. Like the corresponding, yeah, this cell also has the value 0. And then this for 1 value is 1, and here value is 10, here 20, here value of n is 30, 40, 50. And 1, 2, 3, 4, 5. And when we want the answer for 12, we take the value in this cell and the value in this cell. Are these independent? No, no, this is wrong because we know. Yeah, shit. This is like bullshit. This is wrong. This is wrong. This is wrong because we do know that for n equals 2, answer is, I think, 4. And for n equals this, Yeah, answer is 3. But for 10, answer is 3. But for 12, answer is not 7. We don't even have 12. We have 11, where answer is 1. No, where answer is 9. For 0, answer is 1. For 1, answer is 3. Okay, for 1, answer is 3. Let's let him cook, and let's see if this does work. Let this method cook, because if this works, it will be cool. Hello, new to channel. What is your goal in CP and competitive programming? My goal is to reach 2000. Currently, we are struggling with 1600. 2000 is a far cry right now, but the goal is to reach 2000 rating by the end of this year. And why do that? Do that first of all to make a point to myself personally, and also to show you guys that I started like with zero knowledge of what competitive programming is. And so the main goal is going to be to show you guys that you can also do anything you want if you like work hard after it, because I started with zero knowledge of CP competitive programming, and I'm now solving 16, not solving 1600, trying to solve a 1600 rated question. But yeah, the thing is, you can grow, right? Given enough time and enough work, you can grow if you want to. And if you put in the hard work, and you do not have to trust me, because I will be showing you that you can grow. Okay. For 10, the answer is literally 3. For 10, the answer is 3. For 20, the answer is also 3. For 0, yeah, answer is only 1 here. Yes, yes, answer is only 1 here. And here, answer is 3. So for 11, nope, it is not 3 plus 3. Wait, do we multiply? Because we know for 11, answer is 9. And here for 1 and 10, answer is 3, 3. So do we multiply? What other double digit number do we have? We do not have any other double digit number. We only have this big, big, big number. And for 30, 20, 10, 10. No, I think the earlier model was better. Okay, okay, let's be more concrete and rigorous. Can we calculate the value for 30 if we do know the value of 20, 10, and 0 and everything before that? We do know the answer for 3, which is 9. Eh, Would it say for 0 is 1, 1 is 3, and 3 is 10. So its answer for 3 is 10, 2 is 6. So not 4, but 6. 2 is 6. And 1 is 3. 1 is 3, and 3 is 10. 3 is 10. So for 13, is the answer going to be 30? I don't think so. If our strategy is to multiply all of these numbers, I don't think so. Answer is going to be 30. That is just too big. And we can actually fill this whole array. Plus 4, plus 5, 15, 6, 21. Not this, but answer here is 21. And here we are just adding some value to the last value. No, this is just wrong. I think the earlier model was better. 10 power 7 rows and 3 columns instead of this, because this thing is not going to work. Because for 12 is our answer 18. Like, really? Do we have to return modulus? No, we don't even have to return modulus, but the answer will get very big. Okay, we have to find a counter example. Let's first see how this thing is wrong. What is the actual answer for 12? Because for 9 and for 11, n equals 11, it does work if we multiply 3 with 3. 1 plus 10, 3, 3, multiply them together, and we do have the answer. Or yes, we do have the these three ways which are here, and these three ways which are here, they are like totally, yeah, the three ways for n equals 1 are these: 0, 1, 0, 1, 0, 0, and for n equals 10, they are 10, 0, 0, 0, 10, 0, and 0, 0, 10. And how does it make sense to just multiply these two? Yeah, no. So this is like wrong. If I do have these different ways, how does knowing these three different ways help? That does not even make sense. Yeah, sure. Okay, let's start from scratch, right? Let's start from scratch. 13 is 30. 12 is 18. There is one. Wait, wait. Are you sure that 13 is 30 and 12 is 18 for 12? Because like this, how is this thing going to work? I don't think this is correct, because like why does it make sense to multiply the number of rows in this matrix and the number of rows in this matrix and get 9? That does not make sense. Like, no. And how is the status? It is still in queue. Okay. Let's start from scratch. Right? N equals some number. And I'm saying that we have to divide this into A, B, and C. Let's just focus on C for a while. Let's say n equals 53. What are the possible values of C? C can have value 0, it can have 1, it can be 2, it can be 3. Those are shit. Actually, it can have a lot of values. It can also be equal to 4. C can have all the values from 0 to n, and the only thing is the other restraint of digit sum. This thing checks out when C is between 0 to n, there is always something left out. C cannot be greater than n. That is one restraint, and that is why our range is 0 to n. But now the other restraint is the sum of digits, which is here 10, which is here 8. So what we cannot have is the sum of digits of C exceeding this number. Yes, sum of digits of C cannot exceed this number. Shit. Is this going to be like multi-dimensional? When C equals, let's say, 17, then the sum of digits for A and B is 0. That is like not possible. So yeah, so C cannot have a value of 17. Pro calculated. 3 multiplied by 3 multiplied by 2 multiplied by nothing, the 3 multiplied by 5, 3 by 3, 3 multiplied by 6, and then 3 multiplied by 10, 3, 6, 10. The difference is 3, then, okay, so 3 here was multiplied by 3, let's say, and then here 3 was multiplied by 3, and the difference between 1 and 3 is 2, then 3 was multiplied by 6, and the difference between 3 and 6 is 3. Now the next difference should be 4. So since 3 was multiplied by 6 here, and the difference should be 4. So 6 plus 4, 10. 10 multiplied by 3, it is 30. But that maybe that is not. Our brain just looks at patterns. Like it is finding patterns where they do not exist. You have to be more rigorous than that. Let's say if we do have the answer for 11, for 11 the answer was 9. For 11 the answer is 9. Let's go through those 9 states. First 2, 0, the third one 11. Then yeah, and this one has 3 counterparts. Everything has 3 counterparts. This one, and this is like one thing, and another is 0, 11, 0. That is another one. And another counterpart would be 10, 1, 0. This thing has two other counterparts, or more like six other counterparts, 0, 1, and then this 10 moves over, 0, 10, 1, and 0, 1, 10, and 1 as the first one, and 10, 0, yes, and 1, 0, 10. So 6 for this, 3 for this, total 9. Let's say we do have this. How can we change one to another form? We can say that these three are symmetric because these are literally the same elements being shuffled all around. If A, B, and C all are different, then first value could have three possibilities, second value can have two possibilities. Yeah. So total would be 6 if A, B, and C are different. But if two numbers are same, then the number of possibilities is 3. But if three numbers are same, then the number of possibilities is 1. And in this case, two are same, so number of possibilities is 3, and here none of them are same, so there are six possibilities. And if we have something like this, how can we move to another family? I think we reduce 1 and we add 1 to this other number. Yes, and that would give us a new family. Okay, let's think about 12. You did calculate 12 by hand. So let's see if we can get to 12. So we can say we start with this family, right? And here we have two things similar. So the number of possibilities is 3. Number of members this family has is 3. Now let's turn this into another family and take the biggest number C, biggest number, and add it to this number. And take 1 out of this and add it to this number, and we get 1, 11. Now this is totally another family, and there are there are like all of these numbers are different, so 6 possibilities are going to be for this family. Let's turn this into another family by taking the biggest number and adding it first to this number and then to this number. So if we add this to this, we get 0, 2, and 10 as another family, but we add 1 from this to this, what we get is 1, 1, and 10. Here, all of these are different, so there are going to be 6 members in this family, and here two numbers are same, 1 and 1, so 3 members, and that does equal to 18. And that is kind of true. Okay, for 13, let's see for 13. What do we have? For n equals 13, we can begin with this choice, right? And here two numbers are same, so family, there are going to be like 3 members in this family. And if we subtract 1 from this and we add 1 to distinct elements, there are no other distinct elements, there is only 0, so we can add the 1 from this to any of these numbers. So we will have 1, 0, and 12. And this here, all of these numbers are different, so this is going to have 6 members. And we can take the biggest number again. Yes, we can take the biggest number again, and since both of these are distinct, we will add 1 from this to first this and then to this. So when we add to 1, we get this and 11, and when we add to 0, we get 1, 1, 11, and here all of these elements are distinct, so they are going to be 6 members, and only 2 are distinct, so we will get 3 members from this family. And now we again do the same thing, take one number from the biggest number in the family, and we will, since both of these are one same number, we can add this one to any number, does not matter. So 2, 1, and 10, and here all numbers are different, so there are going to be 6 members in this family. And we have 6 plus 6 plus 6, that is not equal to 13, not equal to 30. So you calculated 30, answer should be 30 for n equals 13. What is any other possibility that we can make here? 18, we have answer equal to 24. Is there any other way we can create a family in which all the numbers are distinct? Here the total sum was 4. The sum of digits was equal to 4. Maybe we can, oh, okay, we cannot, of course, brute force this. That would not make sense. And how is the status? It is still in queue. And it has been 3 hours and 38 minutes. Shit, yes. 0, 3, 10. Makes sense. Totally cool. 3, 0, and 10, which has 6 members in the family. So 6 answer is actually 30. How are we able to get the answer? Like, how is this thing working? This thing is working somehow. When we are calculating answer for 13, if you multiply the value at 10 with the value at 3, we do get 30. So is that a coincidence, or like this table is legit? Okay, we are just like hitting in the fog. I see a little pattern in 3 and 12, but cannot exactly calculate in 3 and 12, in 2, in 3 and 12. 3 is 10 and 12 is 18. Okay, okay, okay. The total sum has to be equal to n. A plus B plus C equals n, and the digits should also have the same sum. can this approach work? I mean, the time complexity for this is not a lot. This is like pretty simple. The time complexity is pretty small because at maximum we will have 7 digits. And even if we do 7 into 7, 9 power 7 is not very big. We can handle 9 power 7. What actually is 9 power 7? 47,000, 47 million. That is uh, uh, 4 10 power 7. That is doable. And the number of test cases is 10 power 4. Yeah, I think at this point we are just wasting our time because it might be much better. We just need a new framework to think about this thing, think about a question like this, and it would be much better to look at the editorial, but I will not look at the editorial right now because it would be much better to look at the editorial with a fresh mind. And yes, that would be much better. I think the only question that we have gotten right is this one. And it was worth spending 2 hours on this question. This one was good. Yes. And just before going, yes, I will be like, yeah. Because in 12, the last digit is 10, which contribute to 1, but it's different than 1, so it can contribute to some more combo. Hello, Ligia he. Because in 12, the last digit is 10. The 10th digit is 10, which contributes to 1, which contributes to 1. Yeah, and cool. And solve further. Yeah. Yeah. My goal is, I think I will just rewrite this one once more. This one, partition array, which we got right before, like which we had to look at the editorial for. I will just rewrite the solution to this thing, and that would be the end of today's stream after I write the solution to this thing, to this question, if I remember what we did. And I do remember what we did, I think. With the int size n for int reference a and x and a, we will take an x, and now n answer equals 0. Here we have just taken in the input in this whole part, and now we will iterate value of k equals 1 k. And this one was a good question. This one was like actually a good question, and there was no extra knowledge which we should have known beforehand to solve this question. This was, yeah, there was like no extra knowledge or some exotic algorithm or some exotic data structure that we needed for this question. And this was just a good, better understanding of how things work. And something like this takes time to understand. I don't know. I think, yeah, just solving more of questions at this level is going to help. With that, k smaller than or equal to a square root of n and k plus plus. Now we are going to find all the factors of the number n, and this is how you do it. If when we divide n with k. If we do not get any remainder, then we will process our thing. And we will have for int I is smaller than k, I plus plus, and internally for int j equals 0, j less than, yep, less than n divided by k minus 1. And what are I and j here? I is, since here we are dividing the elements in the array A into segments of size k, I is referring to which particular element in a segment we are referring to. I equals to 1 means we are referring to element at index 1, which is the second element in our segment, and j is going till n by k. N divided by k is the number of segments that we have. So j is telling us which segment are we at, and I is telling us in that segment at which element are we at. Like that is how the world works. And here we will have two values, the current one and the next one. And the current one is a bracket j into k plus I. And the next one is, let's say, y j plus 1 into k from the next segment. That is why we do j plus 1, this. And after this, we will say m equals gcd of m comma absolute difference of x minus y, because that we want m to give the same modulus when we divide x and y with m, and m is the current running best number which gives the same modulus for all the numbers till this point. And after we have gone through all of these numbers, we will see if not m, like if m is 0, then that is pretty cool. Yep, if m is 0, that is like absolutely amazing. Or m greater than 1, because m equals 0 means we can choose any number we want. Or if m is, shit, m is not equal to 1. When m is not equal to 1, then answer plus plus. And now, since k is a factor of m, we have pair, which is if k is not equal to nyk, nyk is like the opposite number with which k, since k is a factor of m of n by k is also a factor of n, which pairs up with the current k and gives us another answer. And if they are different, then we will do all of this shebang there. And that is cool. All we have to do is replace in, let's say, ko, other k equals n by k, and here we will replace, substitute all the k's with ko on the complete line. Yep, and also increase the answer. That is cool. At the end, see out answer with a new line. That does work, but it is still compiling. Not like it is still in queue, so don't know for sure. And for today, that should be the end of the stream. Yep, that is the end of the stream for today. And thank you for being here. Bye.